Grid based on the environment. Today we're gonna make that the code takes into account the environment when spawning the grid tiles. And by that I mean adjusting the height of the tiles and make sure to only spawn tiles when there's a ground under them. So let's get to it. In Unreal I'm directly going to go into my BP grid. And if I go into my spawn grid function, I'm gonna go here where the index is set. Index, which is a vector 2D right now. So it is a float x and a float y. But someone told me in the comments that it was possible to have a vector 2D but of int instead of floats. And that's what we're gonna use. So we're gonna replace our vector 2Ds everywhere in our code by an IntPoint, which is a kind of vector 2D but with integer instead of floats. So let's start right here. I'm going to go on the right and change the vector 2D for IntPoint. Unreal is giving me a warning, but I don't care, so change the variable type, and everything breaks. Okay, awesome. I'm going to compile and start fixing the problems. So I'm gonna start by just connecting the X back and the Y back to the set and replacing the convert node. So that one was easy. And then right here I have two other problems, and this is because these two functions still take a vector 2D as input. So let's change them. I'm going to select the function, go on the right, change the vector 2D for an IntPoint, select the second one, change the vector 2D for an IntPoint. Then I compile, okay, I can connect them, like so, compile, okay, I have a few problems still, I'm going to go in there. So in the grid tile location, it tries to connect an IntPoint to a vector 2D, so we're just gonna reconnect them together, Unreal is going to convert it for us, like so. Right now, if we compile, everything seemed to work, but I know there's a few problems left. So let's go fix them. I'm gonna go in the get tile rotation from grid index first. Right here, if I zoom, I can see that the grid index right there is still a float instead of an int, which is just weird. Actually, if I copy paste it, here we go, it converts it to an int. I don't know why Unreal doesn't make an error for that one. So we're just gonna delete that one and we're gonna replace it by the new one. So I'm just going to drag from it, search for isIntEven, and connect it where it was before. And do the same thing for the y, so connect it like so. And then we can delete the other code and replace it like that. Perfect. Okay, now I don't have any errors left, and that's true, but there's still a few places I want to change the vector 2D for an IntPoint. And the first one is the grid tile count right there. Right now it's the vector 2D, replace it for an IntPoint. There's another warning, change the variable type, it doesn't matter. Then we compile, we're gonna see a few errors. And actually, since we changed the variable type, it resetted the default value, so we're just gonna put it back to 10 by 10, otherwise we won't have any tiles by default. And now we can compile again, and we can go fix the errors. So let's go to the first one. Here, instead of rounding the X, I'm just going to take it and connect it to the -1, compile, okay, next error. Here, instead of rounding the Y, I'm just going to connect it, and same thing right here, instead of rounding it, I'm just gonna connect it. Compile, okay, still an error over there at the beginning. And for this one, it's going to be a little bit different. Instead of just reconnecting it properly, I'm just going to change the tile count right there. And this tile count is coming from the beginning, right here, from the function. So I'm just going to change it to an IntPoint, so IntPoint. Then we can compile, okay. Unreal didn't convert it for us again, but we know that there's an error, so I'm just going to delete all that actually. And I'm just going to take the set from here and move it at the beginning. So I'm just going to recombine those two pins, connect them to the input, and then connect it to the rest of the flow like so. And reconnect it all the way here. Make it a little bit cleaner. Here we go, and delete that. Compile. Okay, we still have an error. Let's go to the next one. Okay, right here. Same thing, I'm just going to convert it like so, and replace those two isFloatEven by isIntEven. Like so, and the second one like so. Then I'm gonna go down, I have to convert it right here, so just reconnect them, and right here, gonna do the same thing. Then if you compile, everything is good now. Perfect. Just gonna save, and we're gonna go test it. So let's go back in entry and press play. Okay, my UI is showing 0 by 0, and if I scrub in there, okay, I have an error. Nice, infinite loop, that's just weird. Okay, Unreal doesn't really tell us what the problem is, but I know what it is, so we're just gonna go change it in the UI. So let's go in our blueprints, debug menu, tabs, tab grid right here. We're gonna go in the graph and we're gonna compile. Here we go, we have a few errors still to fix. I'm gonna click on them. Here, instead of connecting the value straight to the tile count, I have to convert it first, like so. And finally, right here, instead of connecting it directly, I'm just gonna convert it. Perfect. Okay, compile, save, and now everything should be back to normal. So I have my grid, it says 10 by 10 by the UI, and it's the same in the world. If I scrub, it works, my grid changes tile count, and let's say if I go back to see the other ones, the hexagon seems fine, and the triangle seems fine too. Perfect! We can now go to the next step. I'm just gonna stop. Okay, so to scan the environment, we're gonna use line traces. And in my case, I most of the time prefer to just create a new trace channel instead of using one that's already there. That way I have more control of what is using that channel. So let's just go create one. I'm gonna go in Edit, Project Settings, and on the left I'm gonna go in Collision. Here in the trace channels, I'm going to create a new trace channel. For the name, I'm going to name it ground, and the default response is going to be ignore. That way, nothing in the game is going to use the ground channel by default. Let's accept this, and we now have a new trace channel created. Now we're going to go back in our level and select everything that is considered the ground. So this, the platforms, the bridges, the little cubes right there, everything that the units can step on. So let's select all that. So here we go, I have everything selected, so I have all my bridges, my small cubes, but I don't have these big cubes in the back, these big platforms, because I don't want to have any grid on there. So I deselected them, and I selected everything else. And now I'm gonna go in the right and scroll all the way down to the collisions, and I'm going to expand the collision preset. And here I'm going to go down to the channel ground that we just created, and I'm going to make it to block. That way all the platforms and ground and bridges and cubes are going to block that specific channel. And that's it, the level is now set up to work with the grid. We just have to do it for all the other levels now. So I'm going to save that one and open the hexagon one. And in here, same thing, I have to select all the platforms. So here we go, I have all my platforms, my bridges, all the little hexagon right here, right there, and I deselected these hexagon over there because I don't want any grid on there. Then I'm gonna go on the right in the collisions and I'm going to check the ground channel. I'm gonna save the hexagon level and I'm gonna go do the same thing in the triangles. So select all the platforms. Same thing, I selected everything that is considered ground except those ones on the back. I selected the bridges and the small triangles over there, and I'm just going to check the ground channel. And that's it, now all of our levels are set up properly. Okay, it's now time to do the line trace to scan our environment. So I'm just gonna go back in the BP grid, and in my spawn grid function, I'm gonna go right at the end, right before spawning the tile. I'm just gonna move it out of the way, and I'm gonna create a new function that I'm gonna place there. So new function, which I'm gonna name TraceForGround. It's gonna take an input, which is the tile location. So a new vector, which I'm gonna name location. And it's gonna return a vector also, which is gonna be out location. And we also want to know if the trace touched something, so we're just gonna return another output, which is gonna be a boolean this time, and I'm gonna name it hit something. And I'm gonna place it first, just because I think it looks better that way. Okay, we can now go back in the spawn function and connect our function right here. So I'm just gonna connect it after setting the transform, like so. And then we're going to use the transform that we just set before that to set the location input. So I'm just going to take it, split the pin, and connect the location to the location. Then if I hit something, I'm going to do a if right here, and I'm going to set the location again. So I'm just going to set the transform like so. I'm going to use the out location to set the new location of the tile, and then the rotation, the scale as before. And then once that's done, we can spawn the tile the same way we did before. Perfect. But now, all that is in the case that we want to scan the environment to spawn our grid, but it's possible that we don't want to. What if you just want to spawn the grid in an empty world just to test the grid itself? Well, it will be nice to be able to do that, so we're just going to add that possibility also. So I'm just going to add an if right here, in before, and if it's true, it means that we want to scan the environment, which is all the code right here. But if it's false, it means that we don't want to scan it, so we're just going to do the same thing we did before, so the same exact code like so. And to affect that condition, we're gonna add an input to our function. So I'm just gonna select my function spawn grid on the left and create a new input, which is a boolean, and I'm gonna name it use environment. Then if we compile, we can access it from there. We can search for use environment and connect it to our if. Perfect, now I'm gonna compile, and since the default value of use environment is false by default, it means that it's currently going through the whole code right there. So we're just gonna go test and see if it works. So I'm just gonna press play. Okay, I still have my grid and everything works as expected. Perfect. But now we want to be able to go through the first branch. So I'm just gonna go step and go where the function is called. So I'm gonna go in tab grid and then if I go in the event graph and right here in the spawn grid function, this is where our grid is spawned right now. So I'm just gonna check the use environment checkbox. Now if I compile and if I press play, I don't have a grid anymore because it's calling the new code and we didn't code it. So it's normal that it doesn't work. So I'm just gonna go step. Go back in the grid and we can now go in the TraceGround function and we're gonna do the code. Okay, so here, the first question we have to ask ourselves is which trace we want to use. Because let's say if I search for trace right here, I have a few options. I have boxes, capsules, lines, spheres, squares. I have a few things. So what shape do we want to use? Well, I think I want to use a sphere in this case because it's bigger than a line and it works better with an hexagon, triangle, and a square, like it works better with all of them. But we still have a few options. So what do we want to use? A channel, a profile, or objects? Well, since we just created a channel, we're going to use a channel. And we still have two options, either a sphere trace or a multi-sphere trace. The difference between them is just that the sphere trace is going to stop as soon as it touches one object, and the multi-sphere trace is going to continue the trace until it reaches the end. And it's going to return us all the objects that it touches in between. And in our case, I think it's going to be useful to have a multi-sphere trace, so I'm just going to use that one for now. Okay, so for the start of our trace, we're going to use the location, so get location all the way here at the bottom. Then we can add a vector, which is going to be 1000. And then we can minus a vector, which is going to be 1000 in the Z also. That way we're going to start above our tile, 1000 in the air, and then we're going to shoot down, all the way down. And it's going to return all the objects it touches in between. For the radius, I know I'm going to use it multiple times in this function, so I'm just going to create a variable for it, which I'm going to name radius. And we're going to set it before calling our trace, so like so. And for the value of the radius, we're going to use the tile size. That way it's going to adapt to the size of our grid. Then we can split, we're going to use the X, it doesn't really matter, X or Y, but we're going to divide it, otherwise it's going to be a little bit too big. So divide it by 3. And then we can connect it to the radius. Perfect. Okay, next step is the trace channel. So do we want visibility? No, we want the ground that we just created. Trace complex, false, actors to ignore, nothing, it's fine. And the draw debug type, since we want to see how it looks, I'm going to use for duration for now. Then we're going to change that to none later on. Okay, that's all we needed. Now we can connect it to the function itself. So I'm just going to connect it like so. And then we have to return. Okay, so first thing is, did we hit something? Well, we have a return here that should return us if we hit something or not. But it doesn't always work actually. I don't know why, but I had a few instances in which this value right here was true, even though the outlist was empty. So it was causing a few issues and it was not working. So I just stopped using the bool and instead I'm just using the length of the list returned by the function. So I'm just going to search for length, which is going to tell us how many objects are in this list, and we're going to check if it's greater than 0. Then I'm going to do an if right here. And if it's not greater than 0, it means that we didn't hit something. So we're going to return false, I hit something. And then we're going to return the default location, like so. But now what if we hit something? Well, we want to get the first item that we hit for now. So get, which we're going to use to adjust the tile location based on the height of the ground that we just touched. So I'm just going to break the output to access everything in there. I'm going to expand it and get the location, which I'm going to break also. Then I can collapse it just because it's a bit too big. And then I'm going to connect my return right here. So if it's true, we're going to make sure that we hit something is equal to true. And the only thing that we want to modify is the Z of the tile. The X and the Y are already good. So I'm just going to split those pins right here. So split the location, split the out location. I'm going to connect the location X and Y into the out location X and Y. And then we can connect the Z. But actually, before connecting it, I think it's better to snap it to a grid. So snap float to grid, which we're going to base on our grid tile size. So we can get it, split it, and use the C of the grid tile size. That way, if the environment is a little bit too high or too low compared to the grid tile size, it's going to snap to the grid itself. And then we can return it. Okay, everything should work now. So we're going to compile and we're going to go try. So go back in there. If I press play. Okay, I have my line trace, but I don't have a grid. Okay, that's weird. At least the line trace are working, so that's good. What if we change the tile count? Okay, now it works. I have my line trace and I have my grid right there. And we can see that it worked because it didn't spawn anything in the holes of my grid because I don't have any ground there. So when it does the line trace, here it returns false. and then in the spawnGrid function. And because it's false, it's not adding any instances to the grid, because the false pin of the if is not connected to anything. Okay, perfect, so it works. But why didn't it work on the first time? Well, it was a little bit difficult to figure out, but it's because the world is not fully loaded when we try to create the grid, so there's nothing there. And then when we create the grid another time, the world is fully loaded and now it works. So for now, I'm just going to go back in the type grid where we are spawning the grid, so when we are calling the spawnGrid function, which is in the construct, so right here. And between the moment we set the variable and the moment we spawn the grid, we're just gonna add a delay for now, so delay. Which should fix the problem. I'm just gonna add a note to it to do fix later. Because it's not super clean, but it's gonna be enough for today. So then I'm gonna go back in entry and press play, and it works. My grid spawns on play. Perfect. Okay, so take a look at it. Okay, it seems fine. It follows the grid. This tile is a bit higher, but it's way too high. It's not aligned with the world anymore. Like, it's way too high. And if I increase my tile size, okay, yeah, it's the same. Here I have the tiles that are floating above the ground. And this is created by the radius of the sphere. This distance right here is the exact value that we use for the radius of our sphere. So I'm just gonna go stop, go back in the grid, go in the TraceForGround function, and I'm gonna subtract the radius at the end right there. So I'm gonna go minus float, get the radius, connect it like so, and then we can snap it to the grid. And that should fix it. So I'm just gonna compile, go there, press play, and now the tiles are directly on the ground. Perfect. And if I scale my grid a little bit more, okay, it's lagging because of the sphere trace. We're gonna fix that in a little bit. But then, okay, if I zoom, I can see that all my tiles are all perfectly aligned with the ground. They are flickering because it's perfectly aligned. We're gonna fix that also. But at least the height is good. Perfect. But there's a little something I want to show you, and it's for the triangle grid, but because the line trace are a little bit too long right now, it's not really visible, so I'm just gonna go back in the line trace here and make it 100 instead of 1000 in both directions. Now I'm gonna go back in the level, press play. Okay, we can now see the sphere trace a little bit better, and we can see that they are not overlapping each other. They are all perfectly aligned. But let's say if I switch for the triangle instead, here, if we zoom on it, we can see that the sphere trace are overlapping each other because they are a little bit too big. So we're just gonna make them a little bit smaller for the triangle. And just while we're at it, I'm just gonna check for the hexagon, and the hexagon seems fine. Like, they are all perfectly distant from each other. So the radius is good for the hexagon and for the square, but not for the triangle. So we're just gonna fix that. I'm gonna go back in the grid at the beginning here at the radius. Instead of dividing by 3, here I'm just gonna do a select float. I'm gonna take the grid shape, I'm gonna do an equal enum, then I'm gonna check for triangle and connect it to the select float. If it's a triangle, we're gonna divide by 5, otherwise we're gonna divide it by 3. And then compile, and we can go test. The square are still the same, that's good. Hexagon, okay, no, now we don't see much, but yeah, okay, now that's good. And if we wait and then show the triangle, here we go. Now the triangles are not overlapping each other, perfect. Now we're just gonna remove all those debug lines because it makes the game run a little bit slower. So I'm just gonna change the draw debug type to none instead of for duration. And we're gonna revert the plus and minus right here to 1000 and 1000. And now if we go back in the grid, press play, we should now be able to scale the size of our grid without having any lag spikes, so that's good. Perfect. Just a quick note about my hexagon grid. Right here I can see that it doesn't really work because my line trace seems to detect something and it spawns some tiles here and there even though there's no platform here and there. And this is happening because if I eject and let's say I go in show and check my collision right here, and if I zoom on my mesh, I can see here that the collisions are going all around the platform and not following the tiles themselves. So the collisions I gave you in the meshes that I gave you were a little bit broken, so I'm just going to update them. So I'm gonna link them in the description, and then you can just re-import them and it should work. So you're gonna go on the right, go see your mesh right there, and you can right click on it and do a re-import from new file. And select the new mesh I'm gonna give you. And here we go. Now that's done, our hexagons are working perfectly and I don't have any hexagon outside of my grid. Perfect. Okay, now it's time to go fix the flicker that we see right there. It is happening because the grid is exactly at the same height as the world, but we're gonna fix that. We're gonna add a little bit of an offset between the grid and the world. So let's just stop and go in the type grid first. Here I'm gonna add a new slider to adjust the height. So I'm gonna duplicate the spin box of the region delay because I just wanted a float. I'm going to rename it spin box with name underscore offset from ground. I'm also going to change the text to offset from ground. Min-max value, let's say 0 and 10,000, doesn't matter. Min-max slider 0 and let's say 10. The default value is going to be 2. Min-max digit are going to be 2 and 2, not always snap, and the delta is going to be 1. Then we're going to implement the event by scrolling all the way down and clicking on the plus right there. And then we're going to call a function that is inside the grid, but it's not there right now. So let's go create it. I'm going to go in BP grid and create a new function, which is going to be set grid offset from ground. This function is going to take a float as input, so new input, float, I'm going to name it offset. Then I'm going to right click on it and promote to variable, grid offset from ground, like so. And then we're going to use that variable to set the Z location to our instance mesh. So get the instance mesh, set world location, connect it right here, split the location pin, and connect the grid offset from ground into the Z. This call right here is also setting the position in X and Y of the grid in the world, and in this case this is perfect. That's exactly what we want. We want the grid to be exactly in the middle of the world with only a little offset in the Z-axis. So we can now compile and go call this function in the tab. So I'm going to go back in the tab, get the grid on the left, and call set grid offset from ground, like so. Then the next thing we have to do is to set the default value of the spin box in the widget. So I'm going to go in the set default value function. I'm going to go all the way at the end. I'm going to get my grid, get grid offset from ground. I'm going to get my spin box on the left. I'm going to do a set value like so and pass it the variable like that. So now at the beginning, we update the spin box based on the value that is already in the grid. Perfect. Let's compile, and now we have to go back in the grid to change a few things. Because we're changing the world location of our static mesh, it's not going to work anymore. So I'm just going to right click on it and do a find references. Then I'm going to click on the first one and see, okay, this is not where I want to go. It doesn't matter. It's for the mesh and the material. The next one, okay, add instance world space. We're just going to go back to add instance local space instead. So add instance, like so. And we're going to replace the function by this one right here. And we're going to do the same thing right here down there. I'm going to replace the world space by the relative space. Okay, that's good. Then we just need to call our function. And actually, since we're here, I'm just going to remove the offset that we add right there because it doesn't really matter anymore. We don't need it. Okay, and then we have to call our setGridHeight function at the beginning. So I'm just going to go here, right after we set the material of the grid. We're just going to call the setGridOffsetFromGround like so, connect it here and there, and pass it the default value, which actually is empty for now. So I'm just going to select it and change the default value on the right to 2 instead of 0. Perfect. Okay, I think that's it. I'm gonna go back in entry, press play. Okay, no flicker, that's good. And if I slide the set grid offset from ground, I can see my grid going up and down a little bit. And actually, if I zoom in, it looks a little bit better, like so. And you can like write anything you want, let's say 100. You can see that there's a big gap in between, but in that case, like we're probably gonna wanna stay between 2 and 5 maybe, something like that. Okay, so the last thing I want to do before ending this video is to maybe add a checkbox in the UI so we can toggle between a grid that uses the environment to be generated and one that doesn't. So let's go do that. I'm gonna stop and go in the tab grid. I'm gonna go in the designer and create a new checkbox. I'm gonna simply duplicate that one right here and paste it in the vertical box. I'm going to rename it checkbox underscore use environment. And same thing for the text, I'm gonna change it to generate grid based on environment, something like that. Okay, now I can select the checkbox, go all the way at the bottom on the right and implement the event. This event, we're gonna connect it at the same place as we connected all the other events that triggered a grid generation, so like here. So I'm just gonna take the pin and connect it right here. So same place that we had for the location, tile count, tile size, or the grid shape, which is going to trigger the spawn grid function. And in there, we're gonna use the check state of our checkbox to decide if we want to use the environment or not. So let's get the checkbox on the left, checkbox use environment. We can drag from it and search for is checked and connect this into the pin. So if the checkbox is checked, we're gonna use the environment. So let's compile, go back in the level and press play. By default, it's not using the environment because the checkbox is unchecked, but if I check it, here we go, it works. So now we can toggle between a grid that uses the environment and one that doesn't. Perfect. And I guess that's it for this video. In the next one, we're gonna make sure that the obstacles are taken into account by our grid generation, so we don't spawn tiles where there's a tree or walls or something else. But for now, I think it's good enough, so I'm gonna see you in the next one. Bye bye!